Hello everybody, Brad the Guitarologist here with another exciting video today. I have another box opening for everyone. I already know what's in this. Actually, I will spoil the surprise. This is another one of those K amplifiers. I'm not going to spend a whole lot of time on this like the last one, but we are going to install the isolation transformer a slightly different way because I've got a different isolation transformer, a different style. This is actually a new old stock one. I'll show you the isolation transformer, show you how I go about installing this style isolation transformer, the old ones, into this thing. And if that's sounds like something you'd be interested in, stick around. I always like to show the unpacking process in my videos just to kind of get a gauge of how things arrived and how they were packed. This one's got 4 layers of foam and some newspaper, so that looks pretty good. He's got it stuffed on the inside. That looks pretty good. You know, some packing is more shoddy than others, but this gentleman looks like he did a good job, so we are not going to rip into him this time. This one has both of the original knobs, unlike the other one that I just finished. But yeah, let's pull this out of here. This actually looks really good. He's got packaging all the way around. I suspect this rode very well. These are lightweight enough also, especially on the way to me, since they have no power transformer at all. That reduces the weight really considerably. So, you know, it costs a little more actually to ship back than it does to ship to me usually. But let's pull this out and see how well it arrived. All right, looks like it got here in pretty good shape. I don't see any obvious damage or anything, so we're just going to take this back door off. Okay, here we are with the back door off and all the packing material out. One thing he did do was ship it with the tubes installed. These really don't have much holding them in by way of, you know, friction in these pins. So that's probably wasn't ideal, but what he did right was he had actually packing underneath the tubes and on top of the tubes, so they really had nowhere to go anyway. So they look like they've ridden here pretty safely. They were still in the amp, so so that's fine. And they did come all the way from California, so to Louisville, Kentucky. So maybe maybe USPS didn't throw this one around too much like they usually do. This looks like the 42nd week of 1964. So this one I think is slightly earlier than the last one we looked at. Possibly that's the case. Serial number on this one, let's see, 26117. I don't know how that compared. I can't remember what the serial number was on that last one. Do have a little tearing right there. This covering they used on these was very thin stuff. It's almost like paper in consistency, so you do expect some tears and some wear on these, especially after so long. But one great thing about these little amps, man, is that they are, they're all, even though they're thin, they're all plywood. Even the baffles are plywood. So they're built half decently. I mean, they're not, it's not like they're Dan Electro shooting for the Sears market with, basically the cardboard materials. So these are built pretty well. Let's go ahead and pop the chassis out, and we will do the servicing on the chassis, and I'll show you what I think I'm planning to do on mounting the new transformer, and I'll also show you the transformer. Here is the isolation transformer we're going to install in this unit. As you can see, it's Chicago Transformers, otherwise known as Stancor. But I love this box. I mean, this is new old stock. This is mint new old stock. This has been on warehouse shelf or something for a long time. Just what a beautiful box for something that was probably, never paid any mind. 3501 West Addison Street. That's right. That should be near Wrigley Field. What are they, Clark and Addison? Where Wrigley Field is. So somewhere up in that region. So this is the one we're gonna install. And the thing about this one though, it's going to be a little bit more work than the last one, and the reason for it is that right there. Our mounting needs to be on the chassis, and we're going to have to cut a hole for our center leads to come through up into the chassis. This is not a very big transformer. As you can see, it fits in my hand. It's not, it doesn't weigh very much. So I think this is going to be a good fit for this amplifier. One thing that kind of caught my attention was that. I don't know what Basler is. Basler Electric Company, Highland, Illinois. Maybe that's the, I don't know, maybe that's the wholesaler or something like that. But Stancor was the manufacturer. But yeah, just a cute little transformer. I think it's going to look the part in this amp too. Well, this is the reason I film most of this stuff, because you just never know. I did say this thing looked like it rode pretty well, but as soon as I went to take these screws out, look at this. That's not just the chassis moving around, that's the mount. That's the little mounts also moving with the chassis. So something has come loose, and it's come loose on both ends. So this chassis is basically, you know, just flopping. So let's see what we can do about reinforcing that. I might have to get my clamps out and some wood glue and maybe some tack nails or something to, you know, or screws or whatever to get those in there a little better. Alright, here we are with the chassis out, and here are the supports. And as you can see, they're pulling away. They're only held on with one nail. Did they really only put one nail? There's another hole there with nothing there. So I don't know. There's only one nail from what I can see. So maybe we've lost a couple nails. So we need to also make sure that those nails aren't in here flopping around. They could be causing havoc later on. So we'll look for those nails and see if they're here. If they're not here, we will go ahead and just squirt some wood glue down in here and even these up. Put an extra tack nail in, or a screw even, and call it a day on that. I mean that's going to be fun. But with the additional little bit of weight, I mean, again, this isn't a very heavy transformer, but still, that's additional weight. Where if you drop this thing from 5 feet, that's going to want to still go, and it might just be enough to rip one of these out. But we want to try to mitigate that before it happens. So let's shore these up the best we can. Yeah, it didn't take very much to pull this one off, but you can see here it did have some glue at one time, but it only kind of covered this center little section. It didn't come out to here, really. I don't know, maybe there was something, maybe there was a little bit there too, but there were a couple holes. Look, maybe some large staples or something were in it at one time, and maybe like those right there, something like that was in it. Let's see how easy they are to get out. And the other one was really easy. This one's going to make a lie. No, it didn't make a liar of me. But see, there's just, I mean, there was a tiny amount of glue there, but we're going to apply a lot more and glue a little better. So let's do that. Yeah, I should probably get an endorsement or something from Typebond at this point. I've used it on my channel so much. Yeah, we're just going to spread some Typebond over this thing. We're going to do the same to the other side and just kind of put it back in place. I'm going to use the same hole that it came out of to make sure we line it up correctly, and we'll tack that in, and then I'll get a screw the right length and screw this up and cinch it down pretty good, and maybe even put another extra screw in for good measure. We want to make sure we don't go all the way through, so we're going to have to measure our screw length. But let's do that so we make sure this thing doesn't come out of here. Alright, here we are with this thing open, and it looks pretty original, with the exception of the capacitors, which have been changed, and we are probably going to change those again. They look like they're over-spec'd, for one, and for two, that's the space I'm going to need to use to install our transformer. It's going to go up under this section right there where they're sitting, actually. So we're going to get these over-spec'd things out of here, put some 160 volts in here and move them over to this kind of area. and that will free up the real estate. And then the rest of this should go pretty swimmingly, I would guess, because I mean, having already done this once, this is not something that should take too long, so we should be able to knock this out pretty quickly. Alright, I've gotten most of the modifications complete. We changed a couple of the input resistors on this mod. We get rid of a capacitor here, or excuse me, a resistor here. We add a 1 meg grid leak resistor here. We rebias the first tube. And I will actually put a link down in the description, and also at the end of this video, if you stick around, you'll see a link to a previous video I made on basically how to modify one of these in this manner. But suffice it to say, most of the modifications are complete with the exception of the power cord and the installation of the isolation transformer. So let's get to that. Alright, here we are with the transformer installed, and I think it came out pretty nice, actually, if I do say so myself. Worked out very well. Good spot for it. It's not overly heavy. You know, it is obviously going to add some weight to the chassis, but it's not enough weight to really be alarming or anything like that. So I don't think we're going to have any problems trying to ship it back. Let's see, I'll show you what it looks like. Oops, there we go. I mean, actually, it really looks the part. It looks like it was part of this thing from the beginning, so very cool. Well, this turned into a strange one. I plugged this thing in and plugged it into my Variac and started dialing it up, and was measuring with my fluke on the secondary, and I was getting the same on the primary and the secondary, and dialing it up slowly. Well, as usual, whenever my Variac doesn't like something, or when it's too much current is starting to be drawn, you know, it kind of starts to shake and shimmer. The Variac itself will. So as soon as it does that, and you know, that's why I dial everything up very slowly on this thing, because it will actually tell you if too much current is being drawn, if there's a short somewhere, or you know, if there's a problem. And if you do it slowly enough, you're not going to harm the Variac, you know, but and you won't harm any other components either. But on this instance, dialing it up, it was starting to get a little bit of a shimmy. So I measured again, and both of these windings seem to be fine. So unsure what the hell's going on, you know, I unplug. The only thing that's plugged in really to this amp is this switch and the well, really nothing's plugged in. I had the thing turned off on this side, so there was no continuity between these two leads. Measured the continuity, there was none, except through the winding of this transformer. I don't know what the deal is, but apparently there's a shorted winding. This thing is fried. So what I have done is I've actually installed this thing, and you know, assuming it was new old stock, which it looked perfect. I mean, absolutely perfect, off the shelf new old stock. So I didn't even consider testing the damn thing before putting it in, and it wouldn't have mattered anyway, because it would have given me a false reading. It would have, you know, I would have probably, the way I would have tested it is put a small voltage on the input primary and measured and see if I got the same voltage out the secondary, which is what I was getting. However, there's some kind of internal short, because this thing, yeah, anyway, I don't know. There's some kind of short in this transformer. Don't know what it is. Again, nothing's really hooked up on the secondary at all. It's not continuous. So something is amiss. Alright, just to prove there's nothing wrong with the amp, other than that transformer, I've just kind of wired up the wires here as they would have been originally. So it's not, this isn't something that I've done in my modifications or anything like that that's caused a short or a problem or anything. It's on, and you can hear it. Variac's on, it's plugged in, it's dialed all the way up, it's full voltage, and no problems. So I mean, I've got some hum, excessive hum, but that's just because I don't have an isolation transformer. If I had that, it would actually mitigate some of that hum. At any rate, yeah, we're gonna have to get another isolation transformer, take this one out, and I'll be getting my money back on that one. Alright, so I contacted the seller back on this this transformer that I burned up, and he says, yeah man, hey, look at the ad again. Right, basically. And he's like, that thing's for aircraft, and it's made to operate between 380 and 1,000 hertz. And I didn't even notice that. I did not even look at that. I saw 115 primary, 115 secondary, 0.35 amps is, we're good. Oh yeah, we're good to go. Who the hell thinks to look at the hertz? I mean, aerospace, man. I mean, who's out building electronics for aircraft? It's like 999 times out of a million, this would have been just 50 or 60 hertz, no problem. But I have to choose the one that's for freaking aircraft, dude. That's pretty funny. I told him, I was like, oh yeah, duh, I see it now. Looks like I bought a paperweight, didn't I? And basically, yeah, that's exactly what I did. I bought a $20 paperweight or $30 paperweight. Awesome. Okay, I've got a new replacement isolation transformer in, and here's the old one. The new one's obviously not as cute or as cool looking, really, as the old one would have been, which is a bloody shame because, I did drill the holes in the chassis to accommodate that one, and pretty much screwed myself. I guess I should have tested it first, but when you look at something that's new old stock like that, and the packaging was perfect on the inside, it didn't look like it had a hard ride here, all that sort of thing, I had no reason to suspect it of being bad. So stupid me, I drilled the holes and popped it in, and then it popped my fuse and popped itself in the process. So Mojo Jojo thinks I should use this new triad here, which is an N68X, and I think this is going to do the job. Won't be nearly as pretty, but it'll get the job done. Isn't that right, Mojo? One thing I learned from this packaging on this Triad transformer is that not only did Triad have an office or a factory or whatever in Venice, California, which I knew they had one in California, but apparently they had one in Huntington, Indiana as well, which I did not know. Makes a lot of sense that they would have, because being centrally located like that, they would lose a lot of business just locating in California from East Coast people, especially if you're trying to ship transformers. That's something I've always kind of used in my assessments of amplifiers, like, is this transformer original to this amp? Probably or probably not, because this transformer is a Triad and they were made in California, yada yada, to try to make a case for maybe this transformer isn't original, and so forth. But now I know they actually had a transformer, either that might be a warehouse, but it also, I guess, could be you know, a factory in Huntington, Indiana. So I did not know that. Okay, this thing can actually be run for 115 or 230 volts, and it gives you instructions for how to hook these up. And you'll notice down there for 230 volts, use the, or tie the black yellow to the black red. So here's our black wires. So that's the primary, and they've already tied those together from the, either this is from the factory or someone was using this in a 230 volt or 220 system. So don't know. It does have some scuffs and things on it, which leads me to believe this might not be, you know, it might not be brand new, but I think it's going to work though, because we're actually, let's see, meter went off. We're actually getting continuity through that winding, so we're good there. And we may as well go ahead and test this other winding as well. Alright, so that primary was good. Oh, shoot. Well, there you go. And the secondary appears to be okay as well. Alright, I'm not going to get fooled again on this sort of thing, so I've taken those terminals off and just briefly wired it up to the variac there. The milk is really important. You have to set some milk next to your variac to get it to work properly, especially after you've blown a fuse. Milk is really important. So with our milk there, you know, to take any excess voltage off the variac, we're going to test this thing, and we're just going to put through a very, very small voltage. I mean, obviously we're out here on the, these are actually further away than they look, like this. Yeah, they're about to touch. We're going to film it from this angle. Oh yeah, this is going to be great. I'll be like that Middle Eastern guy who always electrocutes himself in every video. So here it goes. We're going to dump the milk on it. Anyway, here we go. So let's just dial it up very, very low. Low voltage. And let's get it off of DC. Alright, 16.5 volts on the input, and let's see what we get on the output. Let's see. I could do like a 9-volt battery test and stick it to my tongue and just guess, you know, whether or not it's about 16 volts. And let's see, that's getting 19 volts out of it. So not perfect. It might be a little bit on the high side. Let me think about this. We might even consider possibly swapping the primary and the secondary around. Let me see if I could find some information on this, whether there's a difference in power rating on the primary and the secondary. A lot of these isolation transformers there is. If there is not, I think I would rather have the higher voltage on the primary than the secondary, because, you know, we have higher voltages now anyway than it would have been when this amp came out. And throwing more voltage on top of that might not be a great idea, but let me think about this. We might do it that way, or we might just see if we can get away with it. We'll do some measurements in the amplifier, if nothing else, dial it up on the variac and see where it takes us, and if there's excess voltage left over, like, you know, voltage potential from the you know, from the end of the you know, the oh shit, what am I trying to say here? If there's excess voltage left over from the end of the filament chain, there we go. Hell, some sleep would be helpful. You know, like if I measure from there to ground at the end of the filament chain and there's, like, I don't know, a few volts left over, we might try to find a resistor to drop the rest of that out so there's no voltage potential there. So we'll see what we've got to do, but at least we have a working transformer now. Alright, here we are with the new transformer installed, and we are going to dial it up solely on the variac and just monitor the secondary here voltage. It doesn't look nearly as cool as it could have, either on the inside or the outside. I mean, you'll never see any of this if you're, you know, just playing through the thing, but, you know, that still bothers me. My bad. You know, it is what it is. But it's got a transformer in it now that will work. I'm certain of that. Or if, well, fingers crossed, let's make sure it's not like freaking, you know, for something John Glenn would drive. before I say anything else stupid. Okay, we're up to 37 volts. Let's just kind of dial it up a bit slowly here. I mean, I on this one I'm pretty confident. I could have just thrown the switch and been cool with this one. I just, you know, but after that last experience, you never freaking know. In voltage, that's all the way up, and that's only at 102 volts on the secondary. Had I installed this the other way, you know, that voltage would be even higher. So I'm not 100% certain how this is going to work out. We'll see, and if I need to, I'll decouple the primary, decouple the secondary, and swap them around, and just add a resistor. But I'm going to test it like this first, just to kind of get an idea. This might actually be the better way to go, because, you know, at least this way we're certain that these tube filaments are going to dissipate all of the available voltage on the secondary. Yeah, the good thing about this, at least, is there is really 0 volts potential between the actual between the filament string and the actual ground. So between those 2 points, there's no potential. So that's a good thing. And I can already tell, compared to the short test we did of this amp in exactly this state, just running directly from the wall, it's actually a hell of a lot quieter. And it would be even quieter still if we had the shielding, the back shield on there. So so that's good. Everything looks okay now, but let's get a guitar plug into it and just kind of preliminarily see what, if anything more we need to do to this. Alright, here's the final gut shot on this example of this K, and made some modifications over even the last one that I did with modifications. I bypassed this 10K resistor on the input, so now it's just going straight to this point. I've left this 0.05 capacitor in. I've also left the 2.2 meg resistor in this position. I have found with this, it actually does some sort of tone shaping and tightens up the front end of the signal. So I've actually re-added that. Also, I changed this capacitor that was in this position from a 0.047 to a 0.022. I experimented with moving this capacitor that goes from the screen to the cathode, trying it from the screen to cathode and also screen to ground. I've tried it both ways. Seems about the same either way, but it may be a little bit more pronounced on the high end, and maybe a little bit punchier going just to the cathode. I've added a 0.47 capacitor. This one's actually way overrated because this is all I had in a 0.47, but I found 0.47 to be a really good value for a bypass cap in this position on the output tube instead of the 20. And again, I think it's down to just differences in input voltage, maybe also differences in the speaker. Really, you need to voice these, as well as any amp, to the speaker you're going to be using. Otherwise, you could really overdrive the wrong speaker and it wouldn't sound right. So every amp really needs to be designed kind of specifically for whatever speaker is being used. Otherwise, it may not work the same way you expect it to. If I were to change this speaker, you know, I may even be able to up this value and up this value as well, perhaps, and get a lot more of a round, boomy sound without overloading the speaker. Everything else pretty much is the same as the previous one that I did. I used a couple of different input resistors here, of course. Kept the 1 meg grid leak resistor here on the first stage. Have a 0.033 capacitor. That is a bypass cap on that first stage. This is the signal cap here going to the next stage, and I've got this little bright cap here of 500 pico. Let's see what else. I did not use the 33K resistor for negative feedback that we saw in the previous one, because we just didn't need it in this example. You know, again, with the slightly lower voltage, I think that changed the character of it just enough where some tweaking was really necessary to squeeze the most out of it. The beauty, though, of having this a little lower voltage is there's zero potential between the actual chassis ground and the common ground, so that's good. Let's see. So yeah, I think we're pretty much ready to check this thing out. I did add a fuse on the that's actually on the wall side, on the primary of this transformer. So it comes in on the primary, goes through, or comes through rather, comes through from the wall, goes through a 2 amp fuse, or maybe no, excuse me, that's a 1 amp fuse. Then goes through the switch, then through the primary, then out the secondary of the transformer. So yeah, I think I have this thing pretty much refined down about as much as I can possibly get it without without changing the actual tubes or any other components. Now, you could probably go through and tube roll and select some really, really powerful tubes for the different stages there, but with the tubes I was given, this thing sounds about as good as I think it's ever gonna. And let's give it a tone test and I'll show you what I mean. So yeah, that's a mid-1960s or early 1960s K model 703. Hope you guys have enjoyed this video, and if you have, please hit the subscribe button below. And for now, y'all take care.